Right now, while you're watching this, there are applications running on your phone that you did not open. You did not launch them. You did not give them permission to be active. You swiped them away hours ago, or you never opened them today at all, and they are running anyway, quietly, continuously, in the background of every hour of your life, consuming the battery you charged overnight, consuming the mobile data you pay for monthly, generating heat inside a device you paid hundreds of dollars for, and sending information about your behavior, your location, and your usage patterns to servers you have never thought about, on a schedule you never set, for purposes that are not primarily about making your life better. This is the thing that nobody who sells you an app wants you to examine too closely. Not because background processes are inherently evil, some of them are genuinely necessary and useful, but because the line between necessary background activity and parasitic background activity is drawn entirely by the developer who wrote the app, with no meaningful enforcement mechanism standing between their decision and your battery life. You are the enforcement mechanism. You have always been the enforcement mechanism. You just were never clearly shown where the controls are. Today, we are going to find every single one of them. And by the time this is done, your phone will run cooler, last longer, and stop working for people other than you. Let's start with the foundational truth that changes how you think about everything on your phone. When you swipe an app away from your recent app screen, that satisfying flick that makes the card disappear, most people believe they have closed the app. That intuition is wrong. Or more precisely, it is partially wrong in a way that matters enormously. Swiping an app away removes it from your visible recent apps list and may stop its foreground activity, the part of the app that displays on screen and responds to your input. But it does not necessarily stop the app's background services. Background services are components of an application that are specifically designed to continue running after you have dismissed the app, specifically to perform tasks that do not require your direct interaction. Music playback, location updates, message sync, push notification listening, download management, and, in many cases, analytics collection, advertising data gathering, the behavioral tracking, and a range of other activities that serve the developer's interests rather than yours. Android's architecture explicitly supports this kind of background operation because many legitimate, useful functions require it. Your navigation app needs to keep updating your location even when you switch to music. Your messaging app needs to receive messages even when you're not looking at it. Your podcast app needs to keep downloading episodes while you're doing something else. These are real use cases with real value, and the background processing architecture that enables them is not a design flaw. It is a deliberate feature of how Android works. The problem is not background processing itself. The problem is that the same architecture designed for these legitimate purposes is also used routinely and extensively for purposes that provide no value to you whatsoever. Let's get specific about what actually runs in the background of a typical Android phone, because specificity is what transforms this from a vague concern into something you can measure and address. 73% of users uninstall apps that drain their battery excessively, according to recent Google Play console data. That statistic exists because the problem is pervasive and noticeable, and the technical patterns behind it are well documented, not as speculation, but as engineering reality that developers have studied and written about extensively. Background tasks that were supposed to make apps better are actually killing the user experience. And the same three deadly patterns keep causing battery drain across dozens of Android apps. The first pattern is the always-on background service, a service component that returns start sticky when stopped, meaning it immediately restarts itself whenever Android attempts to shut it down to reclaim resources. A start sticky service that is running a polling loop, checking for updates, pinging an advertising server, refreshing a data feed, on a tight interval will consume CPU cycles and network resources continuously, fight Android's own battery management systems to stay alive, and drain your battery at a rate that bears no relationship to whether you are actively using the app. Social media applications, news aggregators, and advertising-heavy free apps are among the most common offenders in this category, running background services that fetch fresh content and fresh advertising data on schedules calibrated to the developer's engagement metrics, rather than to your battery budget. The second pattern is location abuse. Location access is one of the most battery-intensive permissions an app can hold because maintaining continuous GPS or network-based location awareness keeps the phone's location hardware active in a state that consumes meaningful power. Many apps request location permission for a feature that requires it occasionally, a local search, a weather display, a store locator, and then use that permission to maintain continuous background location tracking that serves advertising targeting and behavioral analytics functions that have nothing to do with the feature you originally granted the permission for. The distinction between location needed while using the app and location needed all the time is one of the most important permission settings on your phone, and it is one that many users have never examined for the apps that have location access on their device. The third pattern involves wake locks, a mechanism that allows an application to prevent the phone's processor from entering a deep sleep state. When your screen is off and you are not using your phone, Android progressively puts CPU cores into lower and lower power states, eventually reaching a deep sleep that consumes minimal battery. Wake locks are the mechanism by which apps can prevent this from happening, keeping the CPU active even when the screen is dark and the device appears idle. Legitimate wake locks are held briefly and released as soon as the task requiring CPU activity is complete. Poorly implemented or deliberately parasitic wake locks can be held indefinitely, keeping your CPU active throughout the night and explaining why phones with no screen time can still drain from 100% to 60% overnight. Background activity isn't always bad. Some apps need it to function correctly. The problem starts when non-essential apps abuse background permissions. This distinction between necessary background activity and parasitic background activity is the one your phone's own battery management systems are trying to make automatically through Android's adaptive battery feature. Adaptive battery, introduced in Android 9 and progressively improved through subsequent versions, uses machine learning to identify which apps you actually use and which you do not, and applies increasingly aggressive background restrictions to apps that fall into the "you haven't opened this in a while" category. It is a genuine and effective feature that works in the background automatically, but it has meaningful limitations that make manual management still necessary for optimal results. The most significant limitation of adaptive battery is the time window it operates on. It learns from your actual usage patterns over weeks, meaning that a newly installed app, or an app you use occasionally but not daily, may not receive appropriate background restrictions for weeks or months after installation, during which time it can consume resources freely. The second limitation is that adaptive battery's automatic restrictions are less aggressive than manual restrictions. You can apply yourself. It throttles background activity rather than eliminating it, which means apps that are genuinely not needed in the background at all are still doing something in the background, just slightly less than they would be without any management. Now, let's talk about something that most Android users have never seen: the running services view in developer options, which is the most direct window into what is actually happening in the background of your phone at any given moment. Google buries this under developer options, and here's how to access it. Go to Settings, then About Phone, and tap build number 7 times until you see the message, "You are now a developer." Then go back to Settings, then System, then Developer Options, then Running Services. This shows every service currently running on your Android phone, along with the amount of RAM each is consuming. What most users see when they open running services for the first time is surprising in both the number of active processes and the identity of which apps are maintaining them. Games you played once last week, shopping apps you installed for a single purchase, social media apps you swiped away hours ago, utilities you use occasionally, each one maintaining a running service, each consuming a portion of your phone's RAM, some of them holding wake locks that are preventing your CPU from sleeping properly. This view is not just informative. It is revealing in a way that changes how you think about which apps belong on your phone at all. You can tap an item in the running services list and click the stop button to forcefully close the service or application. Force stopping a service from this view is the most immediate intervention available. It terminates the background process instantly. However, force stopping is a temporary measure for most apps. An app whose background service has been force stopped will typically restart the service the next time you open the app, and some apps with persistent start sticky services will restart automatically without any user action. Force stopping is useful for immediate relief, stopping a battery drain you've identified right now, but it is not a substitute for the more persistent configuration changes we will cover later in this script. Let's talk about the battery usage view, because this is the diagnostic tool that most Android users have access to but rarely interpret correctly. Go to Settings, then Battery Usage. This shows which apps consume most power over recent hours or days. Apps appearing at the top, despite minimal active use, indicate excessive background activity. The critical detail in reading battery usage data is the distinction between foreground usage and background usage. An app that appears high on your battery usage list because you used it extensively in the foreground, a navigation app running for 2 hours during a drive, a video streaming app playing content for an hour, is consuming battery appropriately for the activity you were engaged in. An app that appears high on your battery usage list with minimal foreground usage but significant background time is the one that demands your attention. At the end of the day, check the background time number and compare it to the percentage of battery drain it corresponds to. Turn off the background processes for the apps that drain the most battery and have background usage time that matches or exceeds their screen time. If an app's screen time was high but background time was low, you don't need to disable its background usage. This methodology, comparing background time to screen time and to battery consumption, gives you a data-driven basis for deciding which apps to restrict, rather than requiring you to guess which ones are problematic or applying blanket restrictions that might break functionality you actually use. One category of apps deserves particular mention because of how consistently and significantly it appears at the top of battery usage lists with disproportionate background activity: social media applications. Facebook, Instagram, TikTok, Snapchat, Twitter, and its successors, and essentially every major advertising-supported social platform have background services that are specifically designed to maintain engagement metrics, track your behavior across your device, refresh advertising inventory, update notification badges, and perform a range of analytics functions that serve the platform's advertising business. These services run whether or not you are actively using the app. They run while you sleep. They consume battery on a continuous basis because continuous presence is more valuable to their advertising models than conservative resource use is to your user experience. The legitimate function these apps need from background operation is modest: notification delivery, which can be achieved through Android's push notification infrastructure with minimal battery impact. Everything else, the content prefetching, the advertising refresh cycles, the behavioral analytics, the engagement metric collection, is background activity that serves the platform's business at the cost of your battery, your data, and in some cases your privacy. Restricting background activity for social media apps specifically, while maintaining notification delivery, is the single highest impact configuration change most users can make to their phone's battery performance. Let's now go through the specific step-by-step methods for addressing background app activity on Android, from the most basic to the most thorough. The first and most fundamental step is restricting background battery usage at the individual app level. Modern Android versions 9 and above include intelligent background management. Access, settings, then apps, then select the app, then battery, then background restriction to stop apps running in the background selectively. Within the battery settings for each app, you will typically find options ranging from unrestricted, which allows the app to use battery in the background without limitation, to optimized, which applies Android's standard adaptive battery management, to restricted, which prevents the app from running background processes except when you have the app open. Setting an app's battery setting to restricted is the most aggressive option available through this interface, and the one that produces the most significant battery saving for apps that have no legitimate need for background operation. The apps that can safely be set to restricted are those where you actively open the app when you want to use it and do not need it doing anything when it is not on your screen. Games are the clearest example. There is no legitimate reason for a game to run background processes when you are not playing it. Shopping apps fall into this category. Reference apps, utility apps used occasionally, productivity apps you open deliberately when you need them. For all of these, restricted background battery setting eliminates background resource consumption completely without affecting the app's functionality when you actively use it. The second step is managing background data specifically, which is a separate control from battery restriction. Review app permissions through settings to identify which apps have location, camera, microphone, and storage permissions they don't actually need for core functionality. These permissions enable background tracking and data collection. Within each app settings, in addition to the battery management options, you will find a mobile data and Wi-Fi section where you can disable background data for that specific app. With background data disabled, the app cannot make network connections while it is not in the foreground. This prevents the advertising refresh cycles, the analytics pings, the behavioral tracking network calls, and the unnecessary content prefetching that many apps perform in the background. For apps on cellular data plans specifically, this change can meaningfully reduce monthly data consumption in addition to battery benefits. The third step involves location permission specifically, because of how significantly it affects battery drain and how commonly it is granted more broadly than any legitimate use case requires. Navigate to Settings, then Location, then App Permissions. This view shows every app on your phone that has location permission and what level of access they have, all the time while using the app only, or ask every time. Any app listed as having all the time location access deserves specific scrutiny. For most apps, while using the apps only is appropriate and sufficient for the legitimate location-dependent feature they offer. All the time, location access is appropriate for navigation apps when you are actively using navigation, and for apps whose core function is specifically continuous location tracking. Certain safety apps, location sharing apps used deliberately. For virtually everything else, the weather apps, food delivery apps, retail apps, social media apps, all the time is excessive and should be changed to while using the app only, or denied entirely if the app functions without it. The fourth step is using Android's battery saver mode, not just as an emergency measure, but as a deliberate configuration tool. Battery saver is helpful because it can stop background apps Android system-wide without changing every app manually. Battery saver mode, when enabled, applies system-wide restrictions on background activity, reduces processor performance, limits location access, and suppresses visual effects, producing meaningful battery life extension at the cost of some performance and background functionality. For users who want maximum battery life during specific periods, a long day without charging access, travel, or any situation where battery conservation is a priority, scheduling Battery Saver to activate automatically at a certain battery percentage through settings, then battery saver, then set a schedule, ensures that aggressive background management kicks in exactly when you need it without requiring manual activation. The fifth step is the most powerful and most thorough, using the Developer Options Running Services view in combination with battery usage data to identify specific apps that are maintaining persistent background services and applying targeted intervention. The process is straightforward. Open Running Services and make a note of which apps have active background services that you did not intentionally launch. Cross-reference with your battery usage data to identify which of those services are producing measurable battery drain. For each identified offender, apply the combination of battery restriction, background data restriction, and permission review described in the previous steps. For apps where the background service provides no value you depend on, consider whether the app needs to remain installed at all. Removing unused apps is the cleanest way to stop apps running in background because the app is no longer on your phone. The sixth step addresses something that most Android users have never discovered: the unrestricted apps list within Android's battery settings. In some Android versions, particularly on Samsung and other manufacturer-modified Android builds, there is a section within battery settings that shows which apps have been explicitly exempted from battery optimization, meaning Android's own battery management systems are not applying any restrictions to them at all. Apps end up on this list because during installation or first launch, they requested to be exempted, and the user tapped allow without fully understanding what they were agreeing to. Many background services exist specifically to support notification delivery. They maintain a connection to a notification server so that when something happens that warrants alerting you, the notification can arrive promptly. For apps whose notifications you do not value, revoking notification permission through settings, then notifications, then app notifications, achieves two things simultaneously. It stops notifications you did not want from appearing, and it often reduces the background service activity that existed specifically to support those notifications. An app that has no permission to notify you has less justification to maintain a constant background connection for notification purposes, and many apps' background footprint shrinks meaningfully when their notification permission is removed. The eighth step is manufacturer-specific optimization settings, which vary significantly between Android implementations, but which in many cases offer more aggressive background management options than stock Android standard settings. Samsung's Galaxy phones include a feature called Deep Sleeping Apps, accessible through Settings, then Battery and Device Care, then Battery, then Background Usage Limits. Apps placed in the deep sleeping category are prevented from running in the background entirely, except when actively opened, a restriction more aggressive than standard battery optimization. OnePlus and Oppo devices have similar manufacturer-specific aggressive background restriction options under their battery settings. Xiaomi devices have an aggressive battery saver implementation that can be configured to restrict specific apps similarly. Exploring your specific phone manufacturer's battery and app management settings, beyond the standard Android settings that appear across all devices, often reveals manufacturer-built tools that are more powerful than the generic Android controls, and that are specifically tuned for the thermal and battery management characteristics of your specific hardware. Let's address the counter-argument that some users will raise, that restricting background apps causes missed notifications, delayed messages, and broken functionality. This concern is legitimate, but significantly overstated in the context of how to correctly apply restrictions. The key distinction is between apps that use Android's standard push notification infrastructure, which delivers notifications efficiently without requiring a persistent background service, and apps that implement their own notification delivery through persistent background connections. Modern Android and Google's Firebase Cloud messaging service provide push notification delivery that works correctly even when an app's background processes are restricted, because the notification is delivered through Android's own system-level push infrastructure rather than through the app's own background service. Most major messaging apps, email clients, and communication tools use this infrastructure correctly. Correctly restricting battery usage on these apps does not delay or prevent notifications. It eliminates the non-notification background activity that drains battery without serving you. The apps where background restriction does genuinely affect functionality are those where the background activity is the functionality music players that need to keep playing, navigation apps that need to keep tracking, download managers that need to keep downloading, fitness trackers that need to keep monitoring. For these specific apps, unrestricted or optimized background settings are appropriate because the background activity is exactly what you want the app doing. The entire framework of background app management is not about eliminating all background activity. It is about exercising informed judgment about which background activity serves your interests and which serves someone else's. When done correctly, restricting background activity can improve battery life by 20 to 40%. That is not a trivial improvement. On a phone that currently lasts 12 hours before needing a charge, a 20% improvement is 2.5 additional hours. A 40% improvement is almost 5 additional hours. The difference between a phone that needs a midday charge and one that comfortably reaches the end of a full day. These improvements are achieved not by buying a new phone, not by replacing the battery, not by using the phone less, but by removing the resource consumption that was happening on your existing hardware, on your existing battery, without your knowledge or consent, for the benefit of app developers rather than for you. Let's close with the principle that ties every step in this conversation together, because it is more important than any individual setting we discussed. Your phone is a computer. It runs software. That software was written by people whose interests are not perfectly aligned with yours, whose businesses depend on engagement metrics, advertising revenue, data collection, and the behavioral information that your usage patterns generate. The background processes that run on your phone when you are not looking are, in the aggregate, the infrastructure of those business models operating on your hardware at your expense. You did not choose to run that infrastructure. You were not clearly told it was there. And you were not given a prominent, simple, obvious way to turn it off, because a prominent, simple, obvious off switch would be used. And that would reduce the value of the data and engagement these processes generate. The controls exist. They have always existed. They are real. They work. And the improvements they produce are measurable and immediate. They are buried in settings menus under names that most users never think to look for, accessed through developer mode options that require a specific sequence of taps to unlock, scattered across battery settings and app settings and permission settings, and manufacture specific menus in a way that discourages the systematic audit that would produce the best results. That distribution is not accidental. It is the design of an ecosystem where the incentives of app developers and platform operators are imperfectly aligned with the interests of the person holding the phone. You have just done the systematic audit. You know where the controls are, what they do, and how to apply them in a way that preserves the functionality you actually use, while eliminating the background activity that exists for everyone else's benefit but yours. Your phone's battery belongs to you. The CPU cycles your phone performs belong to you. The mobile data your plan provides belongs to you. Every background process running right now that does not serve a function you value is spending those resources on someone else's behalf. Go turn them off, all of them. One by one, starting with the app at the top of your battery usage list that you barely remember installing. The difference will show up by tonight.